So today we're going to start Chapter 7, Section 3, Solving Trig Functions. This is, there's a lot of slides. There's 8 slides, but lots of examples. If it goes too long, I'll do a part 2. So we're going to solve trig functions now. So we're not simplifying them. We're not verifying them. We're actually solving equations with trig functions in it. So the steps that you would have to take, they list them here. Again, you know that we don't always do... we don't always look at these things first, but isolate the trig functions. So get the trig functions by itself. Locate the solution on a unit circle. So once you solve it and get a solution, you try to find that on the unit circle, and then you try to identify all the possible angles that give you that value. These two things we're going to cancel out. And again, this is much simpler when we actually do it in practice. So when I come over here to this slide, for example 1, remember the first thing is get your trig functions together. So what I'm going to start by doing is I'm going to add sine of x to both sides. Okay, and so when I do that, I get 2 sine x plus radical 2 equals 0. And then I'm going to subtract radical 2 from both sides. So 2 sine x equals negative radical 2. And then again, I want to isolate my sine or my trig function. So I'm going to divide both sides by 2. So I get the sine of x equals negative square root of 2 over 2. And then you're going to use your unit circle and you're going to think about that. You know that in the unit circle, let's just kind of think about it, right? All students take calculus. You know that the sign is negative in quadrants 3 and 4. So in 1 and 2, my solution's not going to be there. And then you kind of ask yourself, well, what reference angle has a sine of radical 2 over 2? So I know my reference angle is pi over 4 or 45 degrees, right? But we're working with pi's or radians. So I know that pi over 4 has a sine of radical 2 over 2. In quadrant 3, I know it's going to be pi plus pi over 4, which is 5 pi over 4. And in quadrant 4, it's 2 pi minus pi over 4, which is the same as 8 pi over 4 minus that, so it's 7 pi over 4. So these are my actual solutions. These are the two angles in radians, okay, that have a sine of negative radical 2 over 2. And so those are my answers, and we just solved the equation. So what I'm solving for is this x value. These are the x values or the angle measures that will satisfy this equation, okay? So let's go to number 2. Again, we're going to do the same thing. We're going to add sine x to both sides. And so I come over here and I get 2 sine x minus radical 2 equals 0. I'm going to add radical 2 to both sides, right? And I'm going to divide by 2. And I'm going to get sine x equals radical 2 over 2. And notice that it's positive. So again, my reference angle is still pi over 4. But now I'm thinking about, okay, all students take calculus. In what quadrants is my sign positive? Well, my sign is positive in quadrants 1 and 2. I know that when I have my reference angle, quadrant 1 is the actual reference angle. So that's one answer. And in quadrant 2, it's pi minus the reference angle. And so I know it's 3 pi over 4. And I know those are my two answers. So 3 pi over 4 and pi over 4. Okay, so again, you'll get more used to it as you do more, but now you're starting to understand the process. So again, we come over to here, and remember the goal is to isolate our trig function. So I'm going to add 1 to both sides. Then I'm going to divide both sides by 3. So it's going to equal 1 over 3. Now remember, I'm solving for the tangent of x. I don't want the squared there, so I'm going to have to take the square root of the left and the positive and negative square root of the right. So I know that tangent of x is going to equal plus or minus square root of 1 over square root of 3. I'll rationalize this, right? And I'm going to get square root of 3 over 3. And it's plus minus. So I have to ask myself, what values am I going to have a plus or minus square root of 3 over 3? And when you look at your reference angles, right, I know my reference angle is going to be the pi over 6's. 30 degrees has tangents of radical 3 over 3. So because it's plus and minus, that means all 4 quadrants, okay? So I know that my values are going to be in quadrant 1, it's going to be pi over 6. In quadrant 2, it's going to be 5 pi over 6. In quadrant 3, it's going to be 7 pi over 6. And in quadrant 4, it's going to be 11 pi over 6. And again, you got to get good at those reference angles. Remember, quadrant 2 is pi minus the reference angle. Quadrant 3 is pi plus the reference angle. And quadrant 4 is 2 pi minus the reference angle, right? So again here, it's going to be the reference angle. Here it's pi minus the reference angle. Here it's pi plus the reference angle. And here it's 2 pi minus the reference angle. And that's how we come up with it depending on what we're looking for. And now the last one again, same process, 4 sine squared x equals 3. I added 3 to both sides. Then I'm going to divide by 4. So I'm going to get 3/4. Then I'm going to take the positive and negative square root of this, which is going to leave me with sine of x equals plus or minus radical 3 over 2. Because it's plus or minus, I know it's all 4 quadrants, and I know that my reference angle, again, which angle has a sine or y value of radical 3 over 2, and I know that's pi over 3. So my answers are going to be in quadrant 1, pi over 3. In quadrant 2, it's pi minus pi over 3, which is 2 pi over 3. In quadrant 3, it's pi plus pi over 3, so it's 4 pi over 3. And in quadrant 4, it's 2 pi minus pi over 3, so it's 5 pi over 3. And there are my 4 solutions. So those are the 4 angles that if I was to put them in here, those would give me this, it would satisfy this equation. So now we're going to go to a few more examples, again, more and more examples of the same. So again, we want to combine our terms. We want all of our things to go on the same side. But sometimes it's not as easy as it was in the other slide, right? So let's see what different methods would we employ here. So for these, again, since we're solving, we want to get everything over, all the trig functions on one side. So what we're going to do is we're going to take and we're going to bring over, right, cosine squared x minus 2 cotangent of x equals 0. We're going to factor out a GCF, which we see the cotangent of x is a GCF. And over here, we're going to see that we're left with cosine squared x minus 2 equals 0. Now this is where it gets really interesting. Here what we're going to do is we're basically going to solve just like if we were factoring and we basically set each factor equal to 0. We're going to do the same thing here. We're going to do cotangent of x equals 0, and we're going to do the cosine squared x minus 2 equals 0. So again, you have to ask yourself, when is the cotangent of x equal to 0? Well, that's definitely going to be a quadrantal angle. Remember that it's also going to be the cotangent of x is 0 when the tangent of x is undefined. So you can think of it however you want, or you can just think of your unit circle. Okay, so this is 1, 0, this is 0, 1, well, let me go down. This is 0, 1, this is negative 1, 0, and this is 0, negative 1. And I know that the cotangent is x over y. So when does x over y equal 0? Well, here and here, okay? So I know that the angles here are going to be pi over 2 and 3 pi over 2. And again, even though it doesn't say it, we know that this is a range of 0 to 2 pi. It's one revolution, okay? Includes 0, does not include 2 pi. So we have these two answers here. And then over here, I go cosine squared x equals 2, and then I know square root. So cosine of x equals plus minus square root of 2. Now the problem is that the square root of 2 is approximately equal to 1 point something, okay? And what happens is, remember, cosine is between 1 and -1. It's not going to be greater than 1. And this value is greater than 1 or less than -1. So this is actually not valid, okay? And so the only answers are these two here, okay? So we go over to number 6. Again, we bring the sign over. I know that you're tempted to basically say, well, can I divide both sides by sine of x? Well, you cannot, okay? This is not a valid method. You have to move it all over to the same side, okay? So 2 sine x, you have to set it equal to 0. You've got to factor out your GCF, which leaves you with sine x minus 2 equals 0. So the sine of x equals 0, and sine of x minus 2 equals 0. So over here, which values in this, again, your unit circle has a y value of 0? Well, there's 0 radians and 2 pi radians, right? Also, pi radians over here has it, right? So 0 and pi, 0 radians, pi radians, okay? I don't list 2 pi because, again, 2 pi is not included, right? And then over here, this one, sine x equals 2, and again, sine cannot be greater than 1 or less than -1, so that's canceled. So I only have those two solutions. Now, when I get here, I see this trinomial, which we've kind of taught you to do, and we can factor it. Now, for some of you, you're okay with factoring with the trig functions, and others do not like them. So if you don't like them, remember that you can make sine of x equal to u. So this could be 2u squared. And if you had it like that, you know that your product is -2, your sum is -1, and it's minus 2, 1. So it's 2u squared minus 2u minus 1u minus 1. You're going to group, okay, your GCF is actually 2u here. So GCF of 2u. So u minus 1 here. Oh, I made a mistake here. It's minus 2 plus 1 there. I got it. So this is u minus 1 again. There we go. And then 2u minus 1 is one factor. U minus 1 is the other, right? And now I'm going to replace u. Remember, u, I made it sine of x, and u squared was sine squared x, right? So wherever I see a u, I can plug the sine of x back in. So 2 sine of x minus 1 times 2... not 2 sine of x, sine of x, times sine of x minus 1 here as well. I think that's right. And equals 0. And so now I'm ready to take these and now start the process of solving. So let me just kind of move over to here. So 2 sine of x minus 1 equals 0. And the other one is sine of x minus 1 equals 0. So 2 sine x, move the 1 over, sine of x equals 1 over 2. And again, what values in my unit circle have a sine of a half? Well, when the y value is a half, I know I'm dealing with a reference angle of pi over 6, or 30 degrees. So my sine is positive in quadrant 1 and 2. So it's going to be pi over 6, and it's going to be 5 pi over 6. So these are these two. And then here, sine of x equals 1. And again, those are my quadrantal angles. Where is my sine equal to 1? Well, it's equal to 1 at pi over 2, at 90 degrees. And so this one has 3 solutions. All of these that I boxed off are solutions to number 7. And then again, this last one is going to be another one where I factor. Now again, if you get really good at these, I mean, I know my product has to be 2, my sum has to be minus 3. So again, you can do your guessing and checking in all the different ways. I don't know how you guys want to do it. Some people, again, like to do the u method, so I'll do that. 2u squared minus 3u plus 1 equals 0. Again, I know my product is 2, my sum is -3, so it's minus 2 minus 1. So 2u squared minus 2u minus 1u plus 1 equals 0. Group, group. I've got 2u, u minus 1, minus 1, u minus 1. And my factors are 2u minus 1 and u minus 1. Again, u is representative of sine of x, so 2 sine of x minus 1 times sine of x minus 1 equals 0. And now I set each one equal to 0. So 2 sine of x equals 1, sine of x equals a half. Again, same one as before. If the sine of x, is this the same exact problem? It's the same exact answer? That's so weird. I think it is, though. Yeah, I think so. Anyway, okay, sine of x, again, it's the half, so I know my reference angle is pi over 6. And so I know it's going to be pi over 6 and 5 pi over 6. And then the other one is sine of x minus 1 equals 0, so sine of x equals 1. And again, it equals 1 at the quadrantal angle of pi over 2. So these should have the same two solutions, which is really strange, but it does, unless I completely mess this up. And I just realized what happened here. The first one, I was wondering why these were the same, and they shouldn't be. I made a mistake up here on this one when I wrote it, so I'm going to have to come up to this top one and fix this top one, okay? And I'll show you where I made my mistake. When I wrote this out, I wrote out 2u squared minus 2u, and I did minus 1u, and it's not. It's plus 1u minus 1 equals 0. So when I group it, 2u, right, I'm going to get u minus 1. Here, I do plus 1, and I get u minus 1. So now I've got 2u plus 1, and u minus 1 equals 0. So this becomes 2 sine of x plus 1, and I got sine of x minus 1 equals 0. So now when I move it over, 2 sine x plus 1 equals 0. I get 2 sine x equals negative 1. Sine of x equals negative a half. My reference angle is still going to be pi over 6. That doesn't change, but because my sign is negative, I'm dealing with quadrants 3 and 4. So that means that my solutions are going to be pi plus pi over 6, which is 7 pi over 6, and it's going to be 2 pi minus pi over 6, which is going to be 11 pi over 6. So these are the answers for the first one. The second one is sine x minus 1 equals 0. So sine of x equals 1. And again, at pi over 2, our sine is 1. And so these are my solutions. And so that's why they were different. I made a mistake in number 7, so make sure you check that. Again, we keep going and we find that we're going to have more and more that we have to do. But again, like look at this one. We've got a factor, but now we don't have the same terms, right? And this is where we get the benefit of what we've been learning. For example, we know we can replace sine squared x with 1 minus cosine squared x, right? So we have plus 3 cosine of x minus 3 equals 0. Let me distribute the 2. 2 minus 2 cosine squared x plus 3 cosine of x minus 3 equals 0. And I'm going to combine my like terms, right? So I've got minus 2 cosine squared x plus 3 cosine of x, and it's going to be minus 1. And if I multiply both sides by negative 1, I know that this is going to become 2 cosine squared x minus 3 cosine of x plus 1 equals 0. And so again, now at this point, if you're more comfortable, you can do the whole u squared minus 3u plus 1. I know that my product is 2, my sum is negative 3, so minus 2 minus 1. And so now I'm going to expand this out. 2u squared minus 2u minus 1u plus 1 equals 0. Group, 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 right? Factor out your GCF. 2u, u minus 1, minus 1, u minus 1 equals 0. So it's a little bit of work here, right? So 2u minus 1 and u minus 1 are my two factors. This becomes 2 cosine x minus 1 and this becomes cosine x minus 1 equals 0. So 2 cosine x minus 1 is 0, and cosine x minus 1 equals 0. And again, I'm solving now. So 2 cosine x equals 1, cosine of x equals a half. Cosine x, that means my reference angle is going to be pi over 3. And when the cosine is positive, I'm in quadrants 1 and 4. So it's pi over 3. And it's going to be 5 pi over 3, because that's 1 and 4. And then here, cosine of x equals 1. And I know that that is at 0 radians. And so those are my 2 solutions, or my 3 solutions. So now we're going to move on to number 10. And so again, when I look at this, I see that I have a secant and I have a tangent. And to be able to factor this, it's going to have to be in the same format. So I'm either going to have to convert this secant to tangent, or I'm going to have to convert the tangent to secant. I prefer to work with tangents, so I'm going to do that. So I know that secant squared theta is equal to tangent squared theta, or x, plus 1. So minus 2 tangent squared x minus 4 equals 0. I'm going to distribute the 2. 2 tangent squared x plus 2 minus 2 tangent squared x minus 4 equals 0. And now that I distributed that out, I notice that I have 2 tangent squared x minus 2 tangent squared x. So all I end up getting is negative 2 equals 0, and that's a false statement. And so this means this must be a no solution. So this is just kind of like algebra. You have the same problems that you face in algebra when you do these things, and that's okay. It's still, you're going to solve it the same way, and you're going to have the same situations arise. So when we get to this problem, our initial instinct obviously is to move the sign over and solve, just like we've been doing everything else. And so we say, okay, well, the cosine of x plus 1 minus sine of x equals 0. But then we're going to be stuck here. And we're going to be stuck because none of these are squared. Nothing simplifies to anything else. It's not like tangent and sine or cosine. We can't factor it. And so we realize this is a challenge to solve. And so when you get to these where bringing it over isn't going to help you, you're not going to be able to factor and solve, we have to think of an alternative method. And one alternative method is, remember that once we can square things, our Pythagorean identities come in. And so if we take the left side and square it, and we take the right side and square it, we're going to end up with a cosine and a sine that are both squared, which could eventually help us. And so that's the method we do. But again, whenever we square something, just like we did with square roots and stuff, we have to make sure that we check our solutions for extraneous, okay? And it's very tedious. It's a pain, but you do have to check it. So I know when I square this left side, I'm going to get cosine squared x plus 2 cosine of x plus 1. And over here, I'm going to get sine squared x. Now, if I bring that over, I get cosine squared x, let's say plus 2 cosine x plus 1 minus sine squared x equals 0, like that. And then I can kind of start to see, okay, I might be able to do something here and solve. So one thing that's kind of jumping out at me is that the cosine squared x plus sine squared x, I know equals 1, but I don't really have something for this, so I can't combine those. So maybe what I want to do then is, I know that 1 minus sine squared x is cosine squared x. So cosine squared x plus 2 cosine of x plus cosine squared x equals 0. I'm going to combine my 2 cosine x's here, or 2 cosine squareds. So cosine squared x plus 2 cosine of x equals 0. I'm going to factor out my GCF, which would be 2 cosine of x, and that's going to leave me with cosine of x plus 1 equals 0. And so now I'm going to do each one. So 2 cosine x equals 0, and the other factor is cosine x plus 1 equals 0. When I solve this left side, cosine of x equals 0, I know that what values between 0 and 2 pi have a cosine of 0, well, that's going to be 90 degrees and 270, or pi over 2, and 3 pi over 2. And here, cosine of x equals -1. And again, when is x -1? Well, it's -1 at pi. So I have 3 solutions that I start with, okay? Now what I need to do is I need to check the 3. So sadly, I have to go into the original equation and actually check all 3 of them. So let me just pick a different color. And so if I check it, I'm going to do, I know the first one, I'm going to do cosine of pi over 2 plus 1 equals sine of pi over 2. Well, the cosine of pi over 2, I know is 0 plus 1, and the sine of pi over 2 is 1, so 1 equals 1, and that works. So this is a valid answer. The next one, cosine of 3 pi over 2 plus 1 equals sine of 3 pi over 2. So again, the cosine of 3 pi over 2 is 0 plus 1. The sine of 3 pi over 2 is -1, and 1 does not equal -1, so this is not a valid solution. And lastly, the cosine of pi plus 1 equals the sine of pi. The cosine of pi is -1 plus 1 there. The sine of pi is 0, 0 equals 0, and that works. And so this is valid. So my 2 solutions here are pi over 2 and pi. So whenever you square the 2 sides like this, you have to remember to check for extraneous. Okay? Again, I come to this next problem, and after I work on it for a little bit, I realize I move it over, it doesn't really help me, and I know, okay, this is one I have to square. Okay? So again, I'm going to get sine squared x plus 2 sine of x plus 1 equals cosine squared x. I'll move it over, sine squared x plus 2 sine x, you'll see the pattern, plus 1 minus cosine squared x. I know that 1 minus cosine squared x is sine squared x. So sine squared x plus 2 sine of x plus sine squared x. This combines to 2 sine squared x plus 2 sine of x. Factor out my GCF, 2 sine of x leaves me with sine of x plus 1. Again, all of these are going to equal, well, not there, but starting here when I move it over, it all equals 0. So I set each factor equal to 0. So sine of x plus 1 equals 0. Sine of x equals 0 divided by 2 or 0. So in what quadrants or quadrantal angles have a sine of 0? Well, that's going to be 0 radians and pi radians. So there's my 2 solutions for that one. Sine of x equals -1. And I know that when does the sine or the y value equal -1? Well, that's 3 pi over 2. So these are my 3 solutions to start, but again, I know I'm going to have to check it. So I'll have to come over to here and actually do my checking. So sine of 0 plus 1 equals the cosine of 0. So the sine of 0 radians is going to be 0 plus 1. The cosine of 0 is 1. And so 1 equals 1, and that works. So 0 works. Sine of pi plus 1 equals cosine of pi. The sine of pi is 0. The cosine of pi is -1. 1 does not equal -1, so this is a no. And the last one, sine of 3 pi over 2 plus 1 equals cosine of 3 pi over 2. The sine of 3 pi over 2 is -1 plus 1. Cosine of 3 pi over 2 is 0. So 0 equals 0, check. And this works. So my 2 solutions for this problem are going to be 0 radians and 3 pi over 2 radians. Again, here we come and we see 2 cosine 3t minus 1 equals 0, and this is kind of different than what we've seen up until now. So this one here can be a little bit tricky because it inserts something here that we haven't seen before. And what it inserts is, instead of cosine of x or cosine of theta, it's a cosine of 3t, right? Let's ignore the fact that that says 3t, and let's work this out like you would normally do it, because I think, it'll make sense as we go. The first thing you normally would do is you would say, okay, well, 2 cosine of 3t, and you would add 1 to the other side, and you'd say it equals 1. Because remember, you're trying to isolate your trig function. So now we're going to divide both sides by 2, and you're going to say the cosine of 3t equals 1 over 2. So the cosine of whatever 3t equals, whatever angle that is, has to equal a half. And so now let's think about that. What is the reference angle? Let's not worry about the 3t component yet. Let's just focus on the actual reference angle that this refers to. I know that the degree 3t, whatever that is, the cosine of that has to equal a half. Well, I know that the cosine equals a half with my pi over 6's, my 30 degrees, right? Pi over 6 has a actually, it does not. It's pi over 3, my bad. My 60 degrees have that, right? Because I know that pi over 3 is basically a half and square root of 3 over 2. That's my ordered pair, right, for my reference angle. So again, cosine represents the x value, so my reference angle is pi over 3. And also, I know that my cosine being a positive a half, well, my cosine is positive, all students take calculus, in quadrants 1 and 4. So I know that the angles that we're talking about here is going to be in quadrant 1, it's going to be the reference angle itself. And in quadrant 4, it's going to be 2 pi minus the reference angle, which is going to be 5 pi over 3. Okay? So I know that the cosine of pi over 3 equals a half, and I know that the cosine of 5 pi over 3 equals a half. Okay? So that I know. So now, if the cosine of pi over 3 and the cosine, so again, we have cosine of 3t equals a half, and cosine of, let me rewrite it again, 3t equals a half. So what I'm basically saying then is that 3t has to equal pi over 3, and 3t has to equal 5 pi over 3. So since I know my angles are this, now I can set up my equations. I can basically say, okay, well, my first solution is 3t has to be equal to pi over 3, which means t is pi over, it's like I'm going to multiply both sides by 1/3, so it's going to be pi over 9. So I'm not really solving for the angle, I'm solving for the variable t. Okay, 3t together represent these two angles. Okay, I just need to figure out what t is. So t is pi over 9 in the first problem, and then again here I know 3t has to equal 5 pi over 3, so t has to be 5 pi over 9, and that's my second value. So these are my solutions for t. Okay, I hope that makes sense. I'll do another one. So again here I'm in that same predicament. See, I have here this 2t. So I know that whatever the degree measure that I'm looking for is, 2t has to equal that. So we have to figure out the variable t later. So we're going to start by doing 2 sine of 2t, and we're going to add square root of 3 to the other side, and then we're going to divide both sides by 2, and I'm going to get square root of 3 over 2. So at this point, remember this, okay, I'm going to highlight it. 2t represents the angle that's going to have a sine of radical 3 over 2. So once again, I think about that. The angles that have a sine of radical 3 over 2, well, guess what? It's also this pi over 3, right? So my reference angle is going to be pi over 3 again. In what quadrants is my sine positive? Well, in quadrants 1 and 2. So in quadrants 1 and 2, so I know my value in quadrant 1, the angle is the reference angle, and in quadrant 2, it's pi minus the reference angle, so it'll be 2 pi over 3. So I know that these are the two angles that have a sine of radical 3 over 2. Now, that means that 2t has to equal pi over 3, that angle, and 2t has to equal the angle 2 pi over 3. So again, I'm going to multiply both sides by a half this time, and I'm going to get pi over 6, and here it's going to be 2 pi over 6, which again, I could simplify to pi over 3. So t equals this is one answer, and t equals pi over 3, which is my other answer. Okay, and those are my two solutions. Those are the values of t. So t doesn't represent the angle measure that has that sign. The angle measure that has that sign is pi over 3 and 2 pi over 3. The value of the variable t, okay, is going to be pi over 6 and pi over 3. Okay. And again here, this one says the hint, it says not factorable. So by not factorable, it already is kind of telling me what to do, but again, you might not think of it that way. Let's look at it first and say, okay, we've got sine squared x minus 3 sine x minus 2. So initially, I'm thinking, well, why can't I make sine x, right, equal to u squared is sine squared x, and maybe I'm going to factor this. So u squared minus 3u minus 2 equals 0, and I'm thinking, okay, my product is negative 2, and my sum is negative 3, and I start thinking about my combinations, and it doesn't work. I can't, it's negative 2 and 1 don't add up to 3, positive 2 and negative 1 don't add up to negative 3 either, and so this is where the whole not factorable comes in. This can't be factored the traditional way. So now you think, okay, well, how do we normally solve something that's not factorable? Well, we use the quadratic formula, right? So we use the quadratic formula for it, which you know is going to be normally, right, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The only difference is, instead of x equals, it's the sign of x equals. And our a and our b and our c value are these coefficients, the ones either in front of the u's or the one right here in front of the signs. So when I come over to here, I'm going to look at it, and I know that my a value is 1, my b value is negative 3, and my c is negative 2. And so you'll come to that quadratic formula. So the sine of x equals the opposite of negative 3 plus or minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. So we come here, we get 3 plus or minus 9 plus 8 all over 2. And we come over here, 3 plus or minus square root of 17 over 2. So the sine of x, whatever x is, whatever theta that is, or radian that is rather, is going to be that. So I'm going to break this into two equations. I'm going to do sine of x equals 3 plus radical 17 over 2, and sine of x equals 3 minus radical 17 over 2. At that point, you can either find a decimal for this and then do your inverse, or you can just do the inverse now. So you can do sine inverse and then do 3 plus radical 17 over 2. And this one would be inverse sine of 3 minus radical 17 over 2. And you're going to get your decimals. Let me punch that into the calculator and get those values. This first one ends up equaling 3.7379. And the second one ends up equaling 5.6869. And so again, these are in radians, okay? So again, you know, what angle is this? Well, this one is approximately, it's in the third quadrant, right? It's going to be a little bit more than 180 degrees, and this one here is in quadrant 4. And, you know, I'm not exactly sure, but again, it's going to be somewhere between 270 degrees and 360, or 3 pi over 2 and 2 pi radians.